The Amazon cannot feed itself. Something else does. In the north of Chad, there is a basin where the ground is white and the wind never really stops. It is not sand. Pick a handful up, put it under a microscope, and you are looking at skeletons, millions of them, in every single gram. They belong to algae, plankton that builds its shell out of silica glass in a lake once bigger than all the Great Lakes. The lake is gone. The plankton is not, and about 100 days a year the wind comes back to collect it. And 5,000 kilometers west, on the far side of an ocean, there is a forest that is quietly running out of food. Every year, roughly 28 million tons of African dust settle on the Amazon rainforest, and the forest needs every gram. So, how does the wettest place on the planet end up hungry? Why would a rainforest run out of anything at all? And if something across an ocean is quietly paying the bill, how would you ever prove a delivery you cannot see? Quick promise, this is not an everything is connected video. We are following one element, phosphorus, and the famous version of this story has a problem. Here is the plan. First, why the richest forest on Earth is standing on some of the poorest ground there is. Then the delivery itself, then how you weigh a cloud from orbit, and finally the part almost everyone gets wrong, including me. First things first, because I had this completely backwards. I always assumed a forest that big must be sitting on incredibly rich soil. It is the opposite. Most of the Amazon stands on soil that has been rinsed for millions of years, and phosphorus ran out first. And phosphorus is not optional. It sits in every strand of DNA, and in the tiny battery every living cell uses to move energy. Nitrogen, plants can pull out of thin air. Phosphorus has no such trick. Phosphorus only ever comes out of rock. So how does a forest get enormous on empty ground? By refusing to let go of anything it already has. A leaf drops. Fungi and roots strip it, and the phosphorus is back up inside a trunk before it ever reaches the soil. Every hectare cycles 1 to 4 kilograms of phosphorus that way, every year, which makes the forest look like a closed loop. And on paper that holds up. Whatever arrives from outside is 60 to 180 times smaller than the forest's own cycle. If this were a household budget, the delivery from abroad would be a rounding error, something you would never bother to write down. Except a loop that leaks is not a loop. Every year, rain drags 8 to 40 grams of phosphorus per hectare into the rivers. Out of the soil, down the Amazon, into the Atlantic, gone. A rounding error that never stops is not a rounding error. So, the question is not what feeds the Amazon. The forest feeds itself. The question is who quietly pays for the leak. And for 20 years, almost everyone has pointed at the same place, that white basin in Chad where we started. It is called the Bodele Depression. It covers about 0.5% of the Sahara, and it is the dustiest place on Earth. That is not luck, it is shape. Mountains on either side squeeze the winter wind into a jet that scours the old lake bed. At least 100 days a year, that wind throws those glass shells against each other, and glass this thin grinds to powder. The powder gets lifted more than a kilometer up into a hot, dry slab of air called the Saharan air layer, heading west. Which brings us to the awkward part. How do you weigh a cloud 3,000 miles long that never lands in one piece? You shoot it. A satellite called Calypso spent 7 years firing a laser straight down through the plume, pulse after pulse. Every echo came back with a height and a thickness, so between 2007 and 2013, the cloud got measured in 3 dimensions. The verdict: about 180 million tons of dust leave Africa every year. 28 million tons of that reach the Amazon. Inside those 28 million tons sits something like 22,000 tons of phosphorus. Spread over the whole basin, that is not much. About 1 AA battery's worth of nutrient a year for every 1.5 football pitches, and the leak was that size. So, mystery solved. A dead lake in Chad pays the Amazon's bill down to roughly the right number. Case closed. Thanks for watching. Hold on. In 2020, a team did something the famous studies never did. They traced the plumes back, source by source. The Bodele turned out to be a bad traveler. Its dust gets rained and settled out close to home, long before the ocean. The dust that does cross comes mostly from Djouf, 2,000 kilometers west, and the chemical fingerprints never really matched Chad anyway. It gets worse for the pretty version. A 2019 study checked what that phosphorus actually is, and up to half is not dust. It is smoke. Africa burns every dry season, and the phosphorus in that ash dissolves about 3 times more easily than the mineral kind. For the phosphorus plants can actually use, that study puts smoke ahead of dust almost every month. Same wind, completely different parcel. Boiled down in 3 sentences. 1. The Amazon is not rich because its ground is rich. It recycles almost everything it has, and it leaks only a little. 2. That small leak is paid from across an ocean about 22,000 tons of phosphorus a year, blown in from Africa. 3. The wettest place on the planet is kept solvent by the driest. And we had the return address wrong the whole time. What stays open? How much is dust? How much is fire? And whether the books balance at all. Nobody has closed that account yet. That was Africa's delivery to the Amazon, boiled down. If you like big things made small, subscribe. The pot's already on.